Hi students, welcome back. Let's continue with our subject computer graphics. The next topic is the homogeneous coordinates. Okay, so actually the homogeneous coordinates or the coordinates of the point, if you take xy as a point, and can be represented as a homogeneous coordinates can be represented as a triplet. Okay, so that is x, y and some letter. Okay, so don't be confused, I'll explain. The homogeneous coordinates are generally used in design and construction applications. First of all, these are used in design and construction applications. Okay, and in homogeneous coordinate system, a two-dimensional coordinate. So whatever I said, the xy, these are the two-dimensional coordinates. Okay, so in homogeneous coordinates system, a two-dimensional coordinate positions, that is a x comma y, are represented by triple coordination. So this is a triple coordination, or represented by triple coordinates. Okay, so in homogeneous coordination, if you take the two-dimensional coordinate positions like x, y, z, 3 means x, y, z. So we are talking about the two-dimensional homogeneous coordinates. So in homogeneous coordinates, two-dimensional coordinate position, that is a x, y, are represented by a triple coordinates. Okay, so that triple coordinates like x n, y n, comma h, where x is equal to, so this x is equal to xn by h and y is equal to yn by h. Okay, so this is the representation. So here we perform the translation, rotation and scaling to fit the picture into a proper position. So the picture that has to be set into a proper positions, we have to do translation, rotation and scaling by using the homogeneous coordination. Okay, so first let me explain some examples of representing coordination into homogeneous coordinate system. So let me write that. Example of representing coordinates into homogeneous coordinate system. So we have to represent coordinates into homogeneous coordinate system. Means the coordinates is the two-dimensional coordinates. If you are taking that, you have to represent it into coordinate system. So for 2D geometric transformation, we can choose homogeneous parameter h. Okay, let me write. For if you take the 2D geometric transformation, so if you are talking about the 2D geometric transformation, we can choose homogeneous parameter, that is a h, whatever I said now. It's a triplet value. Homogeneous parameter h to any non-zero value. Okay, for example, take it as 1, that is x, y, comma 1. So this is a homogeneous coordinate system with triplet. X, y are the 2D geometric transformations and y is a homogeneous parameter h. So each two-dimensional positions is then represented with a homogeneous coordinate x, y, 1. Okay. So now let's just, what are the homogeneous coordinates for translations, rotations? Translation using homogeneous coordination, rotation using homogeneous coordinate. Let us see how we are representing that. Translation using homogeneous coordinates. So by using these homogeneous coordinates, what is the formula for translation? Translation, transformation. Okay, so that is x dash, y dash and 1. So this is p dash is equal to 1 0 dx 0 1 dy 0 0 1 x y 1. Okay, so this can be represented p dash is equal to translation into p. The new coordinate, the translated coordinates is equal to translation system, that is a tx into original parameters. Okay, now let's take the another thing, that is a rotation using homogeneous coordination. Rotation using homogeneous coordinates. So for this, the p dash is x dash y dash 1 is equal to cos theta minus sin theta 0, sin theta cos theta 0, 0 0 1 into what is the p? X y 1. So this can be represented as p dash is equal to r into p, where r is the rotation. Now let's take another thing. Scaling with homogeneous coordinates. Homogeneous coordinates. Now let's see the formula for scaling homogeneous coordinates. That is a p dash x dash y dash 1 is equal to scaling with respect to x-axis and y-axis. Sx 0 0 0 sy 0 0 0 1 and xy 1. So it can be represented as p dash is equal to s dot p, that is a scaling. Now let me take the another one, that is a fourth one, reflection using homogeneous coordinates. Okay, reflection using homogeneous coordinates. So reflection is a mirror image. So it can be done along x-axis and y-axis. Let me write first along x-axis. What is the reflection of homogeneous coordinates? X dash y dash 1 is equal to, so it's along x-axis 1 0 0 0 minus 1 0 0 0 0. So this is 1 0 0 1 x y 1. So it can be represented as p dash is equal to reflection about along x-axis into p. So if you take along y-axis, what is the formula? Along y-axis, x dash y dash 1 is equal to, so reflection y-axis, this time minus 1 0 0 0 1 0 0 0 1 x y 1. So this can be represented as p dash is equal to reflection of y into p. So this is how you have to represent the reflection using homogeneous coordinates. And the last one is the sharing. Let me write the fifth type of transformation in the 2D. It's the sharing using homogeneous coordinate. So here also along x-axis and y-axis, the sharing. If you take along x-axis, the formula was x dash y dash 1 is equal to 1 sharing x 0 0 1 0 0 0 1 x y 1. So this can be represented as p dash is equal to sharing or along x-axis into p. Okay, if you take along y-axis, that is x dash y dash 1 is equal to 1 0 0, sharing of y-axis 1 0 0 0 1 x y 1. So this can be represented as p dash is equal to sharing along y-axis dot p. Okay, so finally I can say that so far whatever you are seeing, the translation, rotation, sharing, reflection, everything, so by homogeneous representation we can represent all the transformation in uniform manner. All the transformations means the translations, scaling, rotation, reflection, everything can be represented in the uniform manner. That is P dash is equal to transformation matrix into point P. So that is the initial point. So this is a formula. It's a uniform manner. Means here the transformation matrix is like translation T or S, the scaling, or SHS, X sharing along x-axis or sharing along y-axis, or you can take the rotation R. Okay. So here the transformation matrix, you can keep any one of this method. So this is about the homogeneous coordinate matrix. Thank you.